So on today's sessions, we are going to discuss about biopotentials. So again, this term biopotential origin. So this I have made it like something catchy, like Wolverine the origin. Sorry, X-Men origin, Batman Begins, and the Marie. But actually, the title is syllabus title is the origin of biopotential. So bio potential. So there are two words here. One is bio, another one is potential. So potential we know. So potential means it's a voltage. For voltage, we have another terminology which is called as potential difference. There, specifically, potential difference is the difference between two voltages on two signal lines or one signal line and a ground line. So potential we very well know. Now, the bio always indicates life, biology, life, human beings, animals, and so on. So, if you try to guess what is biopotential, it is nothing but it is the potential differences that is seen inside a biological system. It could be an animal or a human being. So, that's what we are going to see. We'll go with one by one. So, this would have been familiar to you. So this is from Judgment Day. Is it audible?
Yes, sir.
Yeah, yeah, internet connection and unstable on the. So this is Arnold Schwarzenegger, right? So and this is a mechanical system. So trying to mimic human beings. It is basically called as um, a robot or a humanoid. Yeah, that's what I was searching. Humanoid, they'll try to say, and robot, which tends to mimic human beings, is called as humanoid. So whereas the animated GIF files on the bottom, it is also another sophisticated robot. In electronic sense, if you see, the human being is more sophisticated than these mechanical robots because they work in approximately about 5 volt to 12 volt and so on. Whereas we, today you will understand, we work with minus 30 millivolt to positive 90 millivolt or 100 millivolt. So that is the potential that is seen in the body or the entire system works. The mechanical system, the robot also has many systems like instruments and so also system, nervous system, and so on. So more motors in buildings, mechanical robots, and mechanical this one, I mean the human and healers and grow many things that needs to be wondered. And you need, if you see the humanoid. So that is in then the has so so we are humanoid. If you see the program runs on the upper layer of the language is a program. We have excel cells with this person. So in the person, when you see, you might not know who is this, but you might know that he is some scientist, right? So he is called as Galvani. So he did, you can see here that he has a frog. So he did an experiment called as dead frog experiment. So that's where uh, this medical electronics came to start up with, or that's where we understood that there are potentials inside the body. So what did he do is he took a dead frog, and on its limbs, leg limbs, he connected some wires and gave some external potential and made the dead frog to jump. So that was his success, and that's how he proposed that the potential there means that the body works, the human beings works with a potential. I mean, he proved. So it all started with long back, very back, 1791, in the early 1800s. It started with. So we are in 2020, so 200 years plus or 20 years back, he put a seed for the medical electronics. So Galvani is the scientist who did it. So from his, we tend to develop it. See, the basic biologically, if you see, the basic building block of a living being is a cell. So in physics and chemistry, the basic building block will be an atom, whereas in biology it is called as a human cell. And you can divide the human cell, which gives against the atoms, but when you divide it, the human cell dies. So any of the left side is the two-dimensional image of a cell, and the right side is the three-dimensional image of the cell. So it has so many parts like nucleus, or many things, mitochondria, plasma, the cell walls, and so on, so on, so that's not our area of interest. What I'm trying to say is the human cell has so many components associated with it, and this is the 3D model. And one more thing is there are many types of human cells. So this is not the single cell. This is not the single type of cell which the entire body has. The human beings have so many cells. For example, there is something called as stem cell. Even now, people say save the stem cell. So stem cells will transmit on a newborn baby, right? And the toppil and stem cells போகும்பாங்க. So with that, they tend to develop more immune kind of medicines from our own stem cells. For intestine cells, sperm cells, egg cells, epithelial cells, neuron. So this is seen in nervous system, and there are so many. This is not all. So there are so many cells. Every human cell is in a different shape, and it has different components inside, like this, right? But when we divide, so basically, one thing is, every human cell basically have some common components like chlorine, potassium, sodium, and so on, which is going to make the contribution to the potential that is seen inside the body. அங்கதான் நம்ம வரப்போறோம். So before going to that, we should see the difference between atom and an ion. So atom is an unstable chemical component or the basic building block of any matter, living or non-living. So atom is the basic building block, but atom maybe means atom as such will be unstable. That is why it is going for a recombination, right? So in electronics, we should have told about different kinds of uh, means recombination. Either it can share the electrons, or we will add impurities from where the electrons will be contributed, doping, and all these things. Now, uh, there is something called as ion. So ion is as similar to an atom, but it is stable in nature. What do I mean by stable and unstable? Means the outermost electron, means outermost orbit, if it has complete number of electrons, like 8 electrons or something like that, then we call it as stable. Means as such it is complete. It doesn't need anybody else to make it complete. So that is the major difference. So here in the body, we are going to deal with ions. We'll see how. So yeah, see, I have to, the left side indicates sodium atom, and the right side says means is shown the sodium ion. See, normally, so what happens is the proton count and the electron count is always equal in any atom. For example, sodium has 11 protons and 11 electrons. 11 means 2 plus 8 plus 1. So the outermost orbit has 1 electron, so which is not stable. So it should need another 7, right? So here what happens is, if the sodium loses 1 electron, then it becomes sodium ion. It is called Na plus. Suppose if any chemical means any atom loses 2 electrons, then you will call it as, for example, if it is not sodium, for example, if it is sodium loses 2 electrons, then you will mention Na2 plus. If it loses 3 electrons, then you will say 3 plus, 4 plus, and something. So here it is 1 electron, so it is mentioned as Na plus. I will take another chemical component, which is chlorine. So chlorine has 17 proton and 17 electrons. So as an atom, the overall charge is neutral, because protons are positively charged, electrons are negatively charged. Inside that there is nucleus, nucleus neutrons irukku, aduvum neutral. So as such, an atom is neutrally charged. The overall charge is 0. So it is 17 means what? 2 plus 8, that is 10 plus 7. So outermost orbit needs 1 electrons to make it complete or to make it stable. So if it receives 1 electrons, then it is called as Cl minus, because 1 electrons is added. Means what will, why it is minus? It will have 18 electrons, 17 protons. So means negative charge dominates positive. So the overall, the atom will be negatively charged. So negatively charged atom is called as ion, negatively charged ion, or an means anion or cation. That's what we'll try to name it, right? So this, why I'm we're specifically about sodium and chlorine is, I'll come. So this picture indicates a bridge between two valleys. Means there is a valley inside, there are two mountains, it's trying to bridge. So that's what I'm trying to do. So one side chemistry, so one side electronics, so we are trying to bridge it. So in electronics, there is a call. So in electronics, we say the current is a flow of electrons, right? That's what they have taught you from first year or even from 12th standard. Now we are going to see another kind of current, which is called as ionic current. So that is seen inside the body. So that's how where our bridging is. See, this is Wikipedia's definition. So an electric current is a flow of electric charge. In electric circuits, this charge is often carried by moving electrons in a wire. It can also be carried out by ions in an electrolyte. So the flow of electrons uh, is not just current. The flow of ions or ionic movements, to and fro movements, are also is called as an electric current. So what is seen inside the body is the ionic current. You will understand. So that's where I am trying to touch. Hmm. See, now at this point you might have a question, or I have a question: what is the relationship between body and current? So why we are trying to relate these two? So here you can see that the person is trying to work out something. So working out involves in contraction and expansion of muscle. So that's what you know as of now. For example, if I go to next slide, you would understand. So basically, so we are getting into the body. So we saw there are different types of cells, every cell in a different structure, but there are certain common components in every cell. Like it could be a stem cell, or it could be a sperm cell, or it could be any other cell. There is some certain components like sodium and chlorine, potassium. So these will be in the cellular fluid. So this is going to make all the difference. So as at rest, for example, I'm not moving, you're not moving, you have lied down, you have slept. At rest, if any portion of the body is not moving. So at rest, normally what will happen is the here I have shown the cell membrane or cell walls. So what will happen is the positive ions, say sodium ion or potassium ion, will arrange themselves outside the cellular wall or cell membrane, and the chlorine ions will align themselves, will go and organize themselves in the inner wall of the cell. So when we tend to measure the potential of a single cell, so if you take a single cell and try to give it to a voltmeter, you will try to read negative with respect to positive. So you will try to read out a potential which is negative in nature. So in general, the resting potential goes with minus 60 to 100 millivolt, whereas here in the I have shown it, and approximately it is about 17 millivolt. It need not be 70 or 80 or 60 or 100 constant always. Yang range இருக்கு அப்படின்னா, there is a range mentioned because no portion of the body is at can be said at complete rest. Only the complete rest can happen when the person dies, right? Because even if you're sleeping, your heart beats, right? The portion associated with the heart has a movement, and the blood flows in the stream, and the veins, arteries and veins are disturbed, the muscles related to them is still disturbed. Hmm? Mahadeshwar recovering. So that's how it is. So it's a gradient, or I think you have studied a random process, right? So what we do, what do we say, it is a distribution of the values. The values will not be constantly 60 or 100. It is distributed everywhere. So that distribution can be mathematics, la Poisson distribution and the மாதிரி சொல்லுவாங்களா அதெல்லாம் என்னன்னா it's the values are distributed entire graph. So that's what I'm trying to make. So it is not, you need not mention always minus 70. It ranges with um, minus 60 to minus 100 at rest, means there is no movement. So here the cell at rest is said to be polarized. So remember, there's a technical word, polarized. Polarized means the cell is now negatively polarized. So this state is called as polarized. Now what happens is, see, it is at 70 millivolt in our case, remember it. Now what happens when the body tends to move? The movement happens by two means, right? So one is, I tend to move by my own, my brain gives an instruction, nerves do what is necessary. So that is one kind of action. There is another kind of action, or the cell is being disturbed, that is, somebody puts me into, slaps me or puts me into disturbance, or make, for example, when somebody slaps me, the cells inside this area is under an action or a motion. So again the action potential comes. So when the cells are disturbed, so what happens, or is under a motion, through externally or internal means, what happens is the sodium and the potassium ions, it comes inside, and the chlorine ions goes outside the cellular wall. So now during the action, if you tend to measure the potential, means the voltage, it reads around 20 to 30 millivolt at the maximum. So minus 100 it goes to maximum value of 20 to 30 millivolt. So this, the cell at this state is called as depolarized. At rest, it is negatively charged, so we take that as polarized state. Now everything goes upside down, so we call it as depolarized. So the cells is momentarily depolarized due to an action. The action may be internally generated action or externally disturbance. One. So this is what happens when I tend to move. So when I tend to move my arm here, so it is going to go to 30 millivolt, something like that. So now it is not going to be 20 or 30 always. When I stop my movement, now what happens is repolarization happens. Repolarization is an automated, it is a natural process. How do it happens is, there is an activity in the cell which is called as sodium pumping. I've mentioned it here. There is an process, natural process always happens when the cell is at rest, which is called sodium pumping. So what this process does is, this, in the process of what will happen is, these uh, ions, positively charged ions which went inside, comes outside, and this chlorine ions goes inside the cellular wall, thus going to the rest or the initial stage. So this process is called as repolarization, mean it is getting polarized again. So that is why we mention it as a repolarization. So at rest, it is polarized, right? It is at 70 or 100 somewhere. When there is an action, it goes to 20 to 30 positive millivolt. And when the action is over, again it falls somewhere around 60 to 100, something like that. That is why it is a gradient. It means it is a distribution again. So that's how it is. So you can see that. Now coming back to the same picture, this contraction and expansion can be read out using the potential difference. When there is a movement, contraction, when there is a contraction, the cells from polarized state, it goes to depolarized state. So the potential go from minus 70, it goes to plus 20. And when he releases, it goes back to minus 70 or minus 50, something like that. So this activity can be correlated, that is correlated அப்படின்னு சொல்லுவாங்க. இப்போ சிக்னல்ஸ் அண்ட் சிஸ்டத்துல கோரிலேஷன் அப்படிம்பாங்க. It is actually correlation. Inside the body, the ions goes outside the cell and ions comes inside the cell. So positive and negative. So this to and fro motion results in a potential difference. So inside the body, it is ionic current, and all in the electronic equipments, it is called electric current. So that's where. So I have related. See, muscular contraction or expansion relates or results in migration or we move, migration of ions, and that results in the potential difference. So that's all for today. So how do potential, means biopotential, originates? It originates due to the movement of ions inside the body. Where is ions? Ions is there in the cellular level. So inside a cell, there are so many components, biological fluids, so many things inside. So in that, the major contributions are the negative ions and the positive ions, especially due to makes all the difference. So that's all